All right, let's do chapter 2, sample test. If f of x is a function, determine if it's a function. So let's take a look at the mapping diagram. That's one way to do it. In the domain, we have, let's see, I'll just work from smallest to largest, a 4, a 5, a 6, a 7, and an 8. In the range, we have a -1, a 2, and a 3. We have 4 going to 2. 2. We have 5 going to 2, 6 going to 2, 7 going to -1. We have 8 going to a 2, and 8 going to a 3. It was okay to have several things going to a 2, but we have 1 going to many, which is not a function. Now, if you were to do a vertical line test at 8 in the x, 1, 2, 3, 4, 5, 6, 7, 8, we have 2, 8, 2, and 8, 3, which means it would not pass the vertical line test at 8. So it does not pass the vertical line test at x equal 8, or we have 8, 2, and 8, 3, two different outcomes for the input of 8. Something along that line, okay? Number 2, if the following is a function, state why you think it is. If it is not, say why it is not. Well, wherever I draw a vertical line on this, I will only hit the graph at one place. So it is a function because it passes the vertical line test for all domain values. There's no domain that has two ranges. Okay? Now, if I wanted to talk about it, that would be, but now I'm going to need this later here. Okay, number 3. Find the domain for each of the following. F of x in problem 1. F of x's domain in problem 1 was the x's, 8, 4, 5, 6, 7, and 8. Set whose elements are 4, 5, 6, 7, and 8. And I can't use interval notation 4 to 8 because I don't have the numbers between each of these. All right, the domain for this. Well, there's only 2 things you have to worry about for a domain. Can't have square roots of negatives, and you can't divide by 0. No division, and 5x minus 3 can't be negative. So what it can be is greater than or equal to 0. So if I add 3 to both sides, I get 5x is greater than or equal to positive 3. If I divide both sides by 5, and since I'm dividing or multiplying, I have to make sure I'm doing it by a positive and not a negative. If a negative, I have to flip the sign, but I don't on this, so I get x is greater than or equal to, dividing by 5, I get 3/5. So the domain is all numbers such that the numbers are greater than or equal to 3/5. Or in interval notation, from 3/5 to infinity. Notice I'm showing my work where I need to. C. Well, this one has division. Numerators can be zero, but denominators can't. So the x squared minus 4 cannot equal 0. So if I add 4 to both sides, I have x squared cannot equal 4. Which means, taking the square root of both sides, x cannot equal 2, and x cannot equal -2. So here the domain is all reals except -2 or 2. If I did it in interval notation, it can go from -infinity up to -2, but not including it. Union from -2, but not including it, up to 2, not including it. Union from 2, not including it, to infinity. Or I could write the set whose elements are numbers such that the numbers are not equal to plus or minus 2 in set. Okay? 3 ways to possibly do the answer on that. Okay, that's page 1. That was pretty easy. Page 2. Find the domain for this. Well, it looks like domain is the x's, and it looks like it starts at -10 in the x, and oops, is missing 1/2, and is missing, looks like about 2.1 or 2, and then goes up to 9. So the domain is, if I did interval notation, I'll just do that, goes from -10, including -10, up to 1/2, but not including 1/2, union, then it goes from 1/2 up to 2.2. That'll be my estimate. If you do anything close to the correct value there, I'd be happy with that. Half up to 2.2, not including that place, union from 2.2 up till 9, including the 9. So you got to watch out for those holes. Now, if I asked you for the range, it would be from -9 up to 10, and I don't have to worry about the holes because I got values here and here for the hole, and here and there for that hole. So I have all the values from -9 up to 10. But I didn't ask for the range on this one. Now, what are the intercepts? Well, it looks like it crosses back here at, about -8.4 in the x. And it intercepts a point, so I'm giving both coordinates. The next one looks like it's at about -1.8. The next intercept is a y-intercept, and that looks like about 5.8. And that's 0 in the x, 5.8. And no more intercepts, so that's it. Then it says evaluate this function at x equal 3. So if I go to 3, it looks like it's about 1, 2.5. Now, it says find the value of this. It doesn't say find the point or the coordinates. So it would be incorrect to say 3 comma 2.5. That is the point where x is 3, but it just says what is the value, the y value at x equal 3, 2.5. This says what is the y value when x is negative 6. Negative 1, 2, 3, 4, 5, 6. Looks like it's down. The y value is negative 1, 2, 3, 4, 5, 6, 7, 8. Find the local maximums. A local maximum is where air would get trapped. Well, it's not going to get trapped there. It can go right by the edge. It's not going to get trapped there because it leaks out the hole, and not going to get trapped there. So there are none. No hot air trapped. Local minimums. I'm looking for puddles of water. It looks like it would puddle right there. Now the local minimum, I don't need to tell the x. I just need to tell the local minimum, which is minus 9. You could say at x equal negative 4.9, but you don't need to. And there's another local minimum at 4, but we want the minimum, which is a height of 1.8. If you wanted, you could say at x equal 4. But you don't need to. If you tell me the point, you're not telling me the local minimum value. Find the absolute max. Where is the highest place on this graph? And can we stand there? It looks like the highest place is 10. If you want to tell me at x equal negative 10, negative 9.9, you may, but that's the absolute max. What's the absolute min? Is there a very lowest place we can be on this graph? Yep, it's negative 9, and we could be there. It happens to be a local minimum too, but the absolute minimum is negative 9. You can tell me at negative 4, x equal negative 4.9, but all you need is the value. Give the intervals where the function is increasing. Well, that's where you have to go left to right, and it's decreasing. Starts increasing from here. And a lot of students mess up by they say, okay, that's from minus 9 up to here. No, you do it for the x's. Where does it start increasing? At negative 4.9. And if that's where it starts, it's not increasing at negative 4.9, but starts after that. So they're open. 2, when does it stop increasing? At 1/2. And there's another one. It increases, not there, not there. Oh, starts increasing at 4, after 4, but not at 4. Starts as soon as it gets past 4, and it keeps increasing up to the 9, but we're not sure what it does after the 9, so we leave it open there. And that's that one. Okay. This says graph this piecewise defined function. So I could pick numbers less than 1 and put them in there and figure out what this is. Or I could say, oh, this has a slope of 1 and a y-intercept of 2. So that's going something, I'm do it real lightly here, like that. But I do it for x's 1 or less. Actually, not 1, because it's not equal, but less. So it would be an open circle and less. Going on forever. Slope of down 1 for 1. Oh, bad news. That's plus 1. Oh, I did it wrong. No, that is plus 1. Plus 1 is going that way. That would be negative 1. Okay, so up 1 over 1, up 1 over 1, up 1 over 1 would be this diagonal there. Okay, 3x. Well, that would go, has a y-intercept of 0 and goes up 3 for 1, so it would go through that point, that point, that point, and up 3, 1. I'd be that point, so I'm going to lightly sketch it. So it'd go through that point, down 3 over 1. But I'm going to do that from 1. So that would include this spot. So that fills in that circle. Even though it was open for 1, this says this function is defined there. And it is 3. 1 in here, we get 3. And it goes till 3. So that would go up. There's to 2. There's to 3. And it's a closed circle at 3 because it's got the equal. So there's the graph. Now, what are the intercepts? Well, the x-intercepts, again, are points. It crosses the x-axis at -2. This line would, if it went on, would cross at 0, 0, but it doesn't. It stops there. So that's the only x-intercept. Y-intercept, that's on this line, and it hits right there at 0, 2. What's z of -1? At -1, the height is 1. This says, what's the y height at -1? It's equal to 1. We don't do a point. We do the y at -1. Got to learn to read this correctly. This says, what is the y value when x is 1? When x is 1, the y value is 3. What is the y value, the z value, at 4? At 4, the graph doesn't exist. If this extended, it would hit up here someplace, but it doesn't. So this is undefined. We don't know based on this function. Okay. Page 3. It says find f minus g. Well, f is x squared minus 3x minus, notice I'm putting in parentheses, and g is 2x plus 3. I'm putting that one in parentheses. So now I know I have to distribute that minus to this, and I get x squared minus 3x minus 2x minus 3. So I get x squared minus 5x minus 3. That's a filled in dot, so this is multiplication. So I got to take f times g. So there's 2 here, so I got to do first, outside, inside, last. I got to do FOIL. I got to distribute all this. So x squared times 2x, that's 2x times x times x to the third. Then I got to take x squared times the 3, so that's plus, and that's plus, so it's plus 3x squared. Then I got to take the negative 3x times the 2x, that is negative 6. X times x is x squared. Then I got to take negative 3x times 3, so that's negative 9x. These are like terms, and so I get 2x to the third. 3x squareds minus 6x squareds is negative 3x squareds. minus 9x. Now this is not a dot. This is a composite. So I got to put G inside of F. Wherever there's an X in F, I've got to put G. So I'm going to have, the F has X squared minus 3X. Every place there's an X in F, I've got to put G. So I got to put 2X plus 3 for that X. And for that X, I got to do 2X plus 3. Wherever there's an X, I put the parentheses and show that I'm putting in G of X in place of those X's of F. So I've got to square this. And I'm afraid many of you are going to just say, well, that's 4x squared plus 9. But it's not. I got to take 2x plus 3 times 2x plus 3. Squaring means multiplying by itself. So that's 4x squared plus 6x plus 6x plus 9. So I have 4x squared plus 12x plus 9. Then I got to take negative 3 times the 2x, so that's negative 6x. And negative 3 times the 3 is minus 9. So combining like terms, I have 4x squared plus 12x minus 6x is plus 6x. Plus 9 minus 9 is gone. So there's my answer. All right. Now we have to take the x's in f of x up here and replace them with x plus h. So f says x, which we're putting x plus h, squared minus 3x, so I put parentheses and we're using x plus h. That's this thing. We've got that minus, now we got to put x's in place of the x's. Well, that's not going to change the look of it. We're going to subtract all that, so I'm going to write, replace that x with an x, so it's going to look the same, x squared. And to replace that x with an x, what's going to still be minus 3x. And then I got to put that over h. So, like I did up here, I've got to square x plus h. X plus h times x plus h. X squared plus xh plus xh, or hx either way, and plus h squared. So I get, for this first thing squared, I get x squared and 2 xh's, or hx's, 2 xh's plus h squared. Then I got to take minus 3 times both of those. That's why I got to make sure I put the parentheses, so I get minus 3x's minus 3h's. And then I got to subtract this. It says subtract here, so I got to subtract x squared minus x squared. And minus a minus 3x is plus 3x. This is all over h. Now, combine like terms. And as I've said in class, if it doesn't have an h, it should cancel. Here's an x squared, a negative x squared. They cancel. Does have an h, that has an h. They might combine. Is there another term that has an xh in it? Not there, not there, not there, not there. So that's stays. Is there another h squared someplace? I don't see one. Minus 3x. No h's in it? Oh, plus 3x. They should cancel. This has an h, so it doesn't have to. Is there another term with just h? Nope. So I get 2xh plus h squared minus 3h over h. Next place students make a lot of mistakes. They just try to cancel something here. Factor an h out. There's an h in each one of these. So if I factor it out, I get h times, let's see, h times what would be 2xh? I believe that would be 2x. H times what would be plus h squared? Plus h. H times what would be negative 3h? A negative 3. Over h, these cancel, and I'm left with 2x plus h minus 3. Okay. Now, some people get this mixed up. You got to look at this carefully. It says put 2 into G and put into F. Put the G one on top. G is 2x, I'm putting 2 in place of the x, plus 3 over, and F says put 2 in for the x's, so we get 2 squared. 2 squared minus 3 times 2. So I have 4 plus 3, 7. 4 minus 6. So that's 7 over negative 2, or negative 3.5. All right. So this is an x squared, so that's the parent function. So I'm going to start, I'll draw an x-axis here, a y-axis here. Goes through 0, 0, 1, 1, 2, 4, minus 1, 1, minus 2, 4. Those are the 5 points that you should know. You should label some axes here, at least with a couple of spots so I know your spacing. And make the parabola. Okay. Now I have 2 things on the outside and 1 thing on the inside. I can do the outside ones first or the inside first. I will choose to do the outside because there's 2 of them. On the outside, we do them, everything on the outside, it goes like you think, not backwards. So, oh, and I have to graph and describe each step. So this is just the parent function. Y equal x squared, or f of x equals x squared, or h of x equals x squared, or whatever. And it says make sure you put points on them. Okay. Now, if I do the outside, outside does like it says, and it goes in PEMDAS, or order of operations. So we have a multiplying by 2, adding 3. Multiplying by 2 would happen first. This is outside, so it works vertically. So I got to move everything, and it's times 2, and it's outside, so it does that. Stretch it. And you have to say vertically. By 2. And so that's from the x-axis. So if I leave the x-axis there, leave the y-axis here, 0, 0 would stay there. The one that's up 1 will go to up 2. And the one that was up 4 would go up to 8, which is going to be too far up to keep track of, but 4, 8. It'd be someplace up there. So it's now going to look something like this. I didn't do anything sideways because it was working vertically. It's on the outside. And then it says plus 3. Well, that's going to get so high that I'm going to lower the x-axis down here. That's why I want you to draw the axes, and I'll put the y-axis here. And so if I move it up 1, 2, 3, because that's what it says, and it goes in that direction, it would be here, then 1 over, it's up 2, 1 over, it's up 2, 2 over, it's from the vertex, it's up 8, 4 times 2, 8, and here, 1, 2, up, 4, 8. So it's going to look like this. Oh, but I just realized I'm going to get points taken off if I don't go back here and say that's a 2 and that's a 2. Okay, so now this is a 2 and this is a 2. So now I got units. I've got my graph. And I got to explain what happened here. I went up 3. That's pretty easy. And then finally, so I did the 2, I did the 3, I didn't do the minus 1 inside. That's inside. It's the only thing inside. And so it goes opposite of the order of operations, and it does opposite what you think. So subtracting 2, you would think it'd go minus 1, but it goes plus 1. So it goes right 1. And so if I put the y-axis there, make this 2, make this 2, instead of going through 0, 3, it's going to go through 1, 3. And over 1, it's going to go up 2. And back 1, it's going to go up 2. And over 2, it's going to go up 4, 8. Back 2, or back from the vertex. 1, 2, it's going to go up 4, 8. Okay? Seven B. Ooh, we've got an absolute value function. So the parent function is y equals absolute value of x. If I graph that, you should know what the absolute value function looks like. So at 2, it's up 2. So I got units. I labeled it and shown what the parent function is. Looks like everything is inside. So that means everything is going to be working backwards. Now, order of operations says multiply by the negative 2 and then add 1. We're going to go reverse. So we're going to do the opposite of adding 1, and it's inside, so we're working horizontally, going sideways. So we're going to go back 1, to the left 1. So left 1, and so if I make my grid, my axes, and this is 2 and 2, then the V would come down to here. Now, I've taken care of the 1. Now, this is a negative 2 that's times, so it's really 2 things. And here, they're both on the same number, so I can do either one first. I can do the negative, or I can do the 2. I'm going to choose to do, I guess, the 2. This is inside, so it does opposite. Now, 2, it works horizontally, not vertically. Horizontally, it says 2 times as wide. So you think it'd be twice as wide. Nope, it's half as wide. Half as wide. Or better yet, compressed horizontally by 2, or a half if you want. I don't care which way you say that. It's by a factor of a 2. So now that means it gets half as far from the y-axis. And that's what people will miss on this. So if this is 2 and this is 2, let's start at the vertex here. That's 1 away from the y-axis. If I go half as far, it's going to be at the half from the y-axis. This is on the y-axis, so it stays on the y-axis. This point is 2 away, so it's going to go to 1 away. And if I go to the other side, this point is 2 away, so it goes to 1 away. And this point is 1, 2, 3, 4 away, so it goes to 2 away. 1, 2. So this should look like, and I can tell that it's not, I'm doing a horizontal compression because the points I had on this graph didn't go stretch up or down. They just got closer to the y-axis. I know I'm doing a horizontal thing instead of a vertical thing. And then finally, the -2, which will do what? Well, let's see. That's the negative, but it's inside. So it's going to work horizontally, and it's going to do a flip over the axis. Not over the center of the graph, but over the axis. So where it's -1/2 goes to +1/2. Where it's on the y-axis, stays on the y-axis. Where it's -1 goes to +1. Where it's +1, over 1 from there, will go to -1. And where it's -2, it will go to +2. And don't forget to put units. And don't forget the description. Flip or reflect over y-axis. Because that's a horizontal flip, not a vertical flip. Now, I could ask you, tell me what the image of the point, I didn't, but what's the image of the point 2, 2? 2, 2's on the original graph. Where does it go? Well, in the first one, 2, 2 went to 1, 2. And then 1, 2, when we moved it over, it went to 1, 2, and then it went to a half 2 with the compression. And then where did it go? It went to a half 2, and then it flipped over, so it went to -1/2 2. And you should be able to do images of points also. I didn't ask for it on this one, might on the test, okay? All right. Determine whether they're odd, even, or neither. Once again, to do a simple check, I'm not asking for a proof. Put in a number that isn't real special, like maybe 2. If I do put in 2, I get 2 to the third minus 2 times 2. 2 to the third is 8 minus 4, which is 4. Now change x to a -2. So that'd be -2 to the third minus 2 times -2. Now, if this is even, I'll get 4. If it's odd, I'll get -4. If I get anything else, it's neither. Okay? So, let's see here. -2 squared is cubed. -2 cubed. That's -2 times -2 times -2, which is -8. And -2 times -2 is +4. That comes out to be -4. So changing the sign of the x changes the sign of the y. And if you wish to think about this on a graph, 2 gives us 4. -2 gives us -4. It's symmetric with the origin. That's a characteristic of an odd function. Changing the sign of the x input changes the sign of the y output. Let's go to this one. When x is 2, we get 2 absolute value of 2 minus 1. 2 minus 1 is 1. The absolute value of 1 is 1, so I have 2 times 1, which is 2. Now if we do minus 2, we have 2, absolute value minus 2 minus 1. And now the absolute value works on after you do this. So we got minus 2 minus 1, which is -3. Then the absolute value works. It doesn't work on these separately. So we got -3 absolute value, which is 3 times 2, 2 times 3, which is 6. We didn't get the same. We didn't get the opposite. This is a neither. And now I go to here. If I use 2, I get 2 squared minus 2. 4 minus 2 is 2. Now if I use x as -2, I get -2 quantity squared. So that's -2 times -2, which is 4 minus 2, because there's no x on that. So I get 4 minus 2, which is 2. I got the same answer. This one is even. They could all be neither. They could all be odd. They could be some odd and some even, some odd and some neither. I'm not telling you that there's going to be one of each by this sample test. I just gave you one of each in the sample test. Now, each one of these squares is 1 unit, and that should be the graph of this. Has a y-intercept of 6. 1, 2, 3, 4, 5, 6. And P is on the graph anywhere, not just right there, which is what a lot of students think. Create a function for the area of the rectangle. Well, this point is over some x value. This length is x. And the height would be f of that x. The coordinates of this point are x, f of x. X, whatever value, if you were at 3, you'd put 3 here and then find the 3 in this equation to find the y heights. So the area of this rectangle as a function of x, and only x, would be whatever x is. You can't use 2.3 or 2 or something like that, because x is moving. And the height is f of x. Well, that's what f of x is. 6 minus 0.3x squared. That's the area function. You can distribute the x if you want, but that's good enough. Okay. Then it says find the x value. Where should we stop so that we get the largest rectangle possible? And that's when we pull out our calculator and we type in this function. So I go y equals, clear that out, and I type in x parenthesis 6 minus 0.3x squared, close parenthesis. I'll go zoom 6 and see how it looks. Oh, there it is. And x is somewhere over here in the first quadrant, and I want to find when the area, this is the area, is the maximum. It looks like it's about there someplace. To find that, I go second, put it up here where you can see, second, calculate, second trace, but yellow makes it yellow there. And I want the maximum, which is a 4. That's somewhere between 0 and 4. Somewhere between there is where it's at. 0 is the lower bound, enter. 4 is the upper bound. I think it's about 2 or 3. I'll just guess 2. And it says, no, it's 2.58. And the maximum is 10.32. Find x where it gives you maximum area. The maximum area is 10.327, but I said find the x value, so I want x is equal to 2.58 is close enough, approximately. Okay.